Alright, in this video we're going to start the discussion on looping. There's three types of main looping mechanisms. The while loop, which I'll talk about in this video, the for loop, which I'll probably talk about in the next video, and the third one is called the for each loop, and that will be saved until later on because there's one other thing I'll have to talk about before I show the for each loops. Looping is the idea of repeating, like a line or multiple lines of code um, multiple times without having to write it multiple times. For example, if I wanted to print, count from 1 to 10 and print that on the screen and have each number on its own line, I could do something like print 1, print 2, print 3, and so forth and so on. And then you could see, just as we would expect, what do I call this? That would print 1, 2, 3 to the screen. Which, in a small case like that, it may be easier and more efficient just to type out the code if you want to do that. But say you wanted to print from 1 to 100 with each one on its own line of code. Well, you're not going to really want to type 100 lines of code just to do that. So that would be a very simple case of using a while loop in one form. There's actually two forms, which is count control and sentinel. This is the count control version of looping I'm talking about. And I mean by count control is you're gonna keep a count because you know how many times you want it to loop. Either as you write the code, this loop needs to run 10 times, or maybe you get a value from a user saying I want this, where you would know the number of times the loop would run. The basic syntax for a while loop is the keyword while, followed by, this is very similar to the if statement. You'll have some condition in here that can be evaluated to true or false. And then in this case, as long as the evaluation turns out to be true, the while loop will continue to repeat. So you'd have your condition in here, followed by the colon, and on the next line you'd tab over, and then as long as you're tabbed over, all the code that's tabbed over one more indentation level would be ran inside the while loop. So, for example, to do, let's say, count to from 1 to 100, instead of saying print 1, print 2, print 3, print 4, etc., we could start a variable, let's call it count, and we'll set that to 1 because we want to start counting at 1 and end at 100. And we could say while count is less than or equal to 100. Now the reason we're doing less than or equal to is if we actually say, well, it's less than 100, then it would loop one less time than we wanted to, because since 100 is not less than 100, it would stop at 99. And on the next line, we could simply say print count, and then after that we'd say count equals count plus 1. And I'll explain this line momentarily. I just want to show you how it works here. And you can see with these, 4 lines of code, including the original assignment, we'll be able to run this, and it'll count all the way from 1 to 100 using 4 lines of code instead of typing out 100 lines of code. That's a very simple example, but it shows you the usefulness of looping. It'll save you a lot of time and headache. Now let me break this down for you. I started count at 1 because that's the first value that I wanted to print out was 1, because we wanted to print out from 1 to 100. And then I had this condition that says count is less than or equal to 100. So as long as count hasn't made it to 101, because anything below 101 would be less than or equal to 100, then we'll print it. And then after this we have this line that says count equals count plus 1. Well, with the assignment operator, what will happen is all the stuff on the right gets calculated before it's saved into the variable that on the left hand side. So what we're doing is getting the O value of count, adding 1 to it, and overriding the count variable. So we can just kind of step through this a few times so you can see the idea. We'll start with 1, and we'll say while 1, because it's what's inside a count, is less than or equal to 100. Well, 1 is less than or equal to 100, so that's true. So we do what's inside of here. We print out the value of count, which is 1. Then we say count equals count plus 1. So 1, which is the current value of count, plus 1 equals 2, and we save that into count. So count now has the value of 2. So then we go back up to here, and we say Is 2 less than or equal to 100? Well, yes, it is. So it's still true, so we still do what's inside of the while loop. We print out the count, which is 2 now. Then we say count equals count plus 1. So 2, which is the current value of count, plus 1 is equal to 3. So this 3 gets overwritten into the count variable. And we repeat the process until eventually, by incrementing the value in count 1 each time, eventually we'll get to the point where we'll say count will be equal to 101. And then we'll say, is 101 less than or equal to 100? No, it's not. It's greater than 100. So then we just skip over this code and we go down to here and run any other code that we actually had set up down here. And that's the basic on count control loops. You can see tons of examples in Google and things like that. I don't want to bombard you with the same idea over and over and over again and make this video 40 minutes long. So you can kind of look at other examples and play with it and you'll see the idea. But I will show you the other form of looping, which is called sentinel looping. That's where you, with the example here, this is count controlled looping, which means that we know that this thing needs to run a total of 100 times, between 1 to 100. Sentinel control looping would be a situation where you have no idea how many times the thing is going to run. A perfect example of this, just to make it bare bones easy, is we'll say we're going to have some code that runs as long as the user keeps saying he wants to run it. So let's just say we'll do a string called input, just the user's input, and we'll use raw input to get an answer from the user saying, we'll just say simply continue. I'll use a really easy example here with no real backing. And we'll say y/n, yes or no, kind of typical thing you'd see like in a command prompt type program. Then we'll say while input equals true. Sorry, brain just shutting down there a second. While input equals true, we'll just keep asking the same question over and over again until they say, I'm sorry, not true. Y equals y, because they enter y or n. So as long as they enter y for yes, then we'll keep asking them if they want to continue until they hit, well, you know, we'd expect them to hit n, but basically as long as they don't hit y, which represents yes, then it'll keep looping indefinitely. This is a very simple example of sentinel loop because we have no idea how many times the user is actually going to hit yes and that they want to continue. And, you know, as a matter of fact, they could hit, you know, put an n right here for no, and this loop would never run in the first place. But what it would do is get the initial yes or no from them, the y or the n, and as long as they entered, if they enter y, this would be true because y, which the value inside here would be y, which is equal to y. So we just simply ask them again, and it would keep looping indefinitely until eventually they hit something else like no or some other value. Just to show this thing in action, this is enter y or n, yes, 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 and I can just do this as long as I want. It's sentinel control, which means there's not a specific count to it. It'll just keep going forever. Whoops. Until, you know, so I'd say I could do it 3 times, then I could hit N and quit. And that's going to actually bug me right here. I forgot to put, with this raw input, you need to actually put, if you don't want it butted against the answer, butted against the question, you actually need to manually put a space in there. I forgot to do that, and that bugs me to death when I do that. But anyway, that's the idea for a sentinel control loop. So once again, count control would be like the first example I gave, where you have an idea, either a direct idea from the beginning of how many times the loop needs to run, or you can get like maybe an idea from the user on how many times it needs to run. Sentinel control is just, you know, it's conditional. You have no idea how many times it's going to run until, it might be something until the user tells you no, or if you're doing networking, you may have a loop run code until you get a certain signal from the server or from the user. I can roll this back real quick to what it was. I can show you another example what I'm talking about when I say you can have count control and you don't know how many times it needs to run, or you know, well, where it's count control but you don't directly have the number when you first start. You could actually do something like like raw input, and say just say something like enter number to count to. And on the next line, we could just convert this to an integer because that's what we expect, and we can say int to convert count. And what this would do is take a copy of the count's value, convert it to an integer, and then just override it back into the count variable. And then here, we could say, and we'll have to do this a little bit different. We'll have an initial count variable that equals 1. And we'll say, I'm just kind of typing this as I go, and then I'll explain it. Bear with me 1 second, I'm almost done. In this case, it's still going to be count control because when it's all said and done, we're going to have an idea of how many times it needs to run, even though we don't actually directly know it at the beginning, or we could hard code it. What I'm doing here is I have this initial count variable that I set to 1 because I know my starting point to count is going to be 1. And then I ask the user how far they want to count. They give me that value, and as I was talking about in the input-output video, everything that comes in from the console's user input's always going to be in a string format, but we need a number. So I use this next line, this int conversion, to convert it to an integer or a whole number. And then from here, the basic idea, it looks different, but the basic idea is the same as what we did originally in the first example. I have the initial count, which starts at 1, and each time I do a comparison it's true, I'll print out that value, that initial count value, and then I'll increase it by 1. And I'll keep doing this as long as it's less than the value that the user entered. So there's still going to be a set number of times it runs from the point that we hit it, actually hit the while loop, because if the user enters 5, it's going to run 5 times. If they enter 30, it's going to run 30 times. So once we get here, we'll have an idea of how many times it's going to run. It's not just like some indefinite unknown occurrence there. But that's that's also another form of the count control loop where you don't actually hard code the value of the number of times it runs in. And we can show this again real quick. Say enter the number to count to. We'll just say 5. And what I mistyped something. Mistyped a variable or something here, I guess. You just recopy all these. Didn't even notice that, but I misspelled that. Anyway, try that again. But, we'll say count to 5, and it counts to 5. We can say count to 30, it counts to 30. That's the gist of it. In the next video, I'll discuss for loops, which are while loops you'll typically use for sentinel control, or you can use for count control. The for loops, which I'll talk about next, you typically only use for count control. Type looping. So stylistically, it's often a good idea to reserve while loops for the sentinel style looping, the unknown. This is the second example I gave you because you don't know how many times it's going to run. And you'll use the next example, the for loop, for count control loops. That's a good way. If you get in that habit, then when you see your code, it'll kind of make stuff flow a little bit better and be easier to catch mistakes.